Can you find current? Current equal to voltage by resistor, I equal to V by R. So V is 14.6 and resistor is 12.6 K. Right? So 14.6 divided by 12.6, how much? 14.6 divided by 12.6. 1.16, but it is not 1.16 ampere. What is the answer? 1.16 milliampere, because this kilo, it is in the denominator. Kilo means 10 power 3. Right? When it goes to the numerator, it becomes 10 power minus 3 milli. So the answer will be 1.16 milliampere. 1.16 milliampere. Okay, so the maximum current which flows through the circuit is going to be 1.16 milliampere. Okay, so now you know what is current. Right? What is the value of current? The current value is 1.16 milliampere. Okay. Now find the power dissipation across 10K, power dissipation across 2.6K. Power dissipation is I square R. So 1.16 milliamp the whole square. Okay, include milli, don't exclude milli, include milli and do it. The 0186 for 10K. Is it for 10K? Okay. 0.0186 watt. 0.08. Okay. So Abdul says 0.018 watts is the power dissipation for the first resistor. The second resistor, Moria says 0.96 Moria. Is it for 2.6K or 10K? Point 0049. So everyone please check. But the power dissipation for 10K is 0.018 watts and for 2.6K it is 0.0049 watts. Please check and confirm your answer. We are going to find what size of resistor we are going to install, correct? So we have taken the circuit assuming that the maximum battery pack voltage is going to be 14.6. So that is the reason this 14.6K. And two resistors are in series, 10K and 2.6K. That is our configuration, correct? 10K and 2.6K. Okay. Now the question is that we know what value of resistor. We don't know what size of resistor, because for the same value, I have shown you different sizes of resistor. To find the size, we need to calculate what is the power dissipation, how much power that particular resistor is able to handle. How do I find it? I know that power dissipation is equal to PD, power dissipation is equal to I square into R. The current flowing through the resistor into the value of square into value of resistor. So square of the current flowing into resistor value. Now how do I find the current flowing through the circuit? It is very simple. We have to apply Ohm's law. Current equal to voltage divided by resistor. Since 10K and 2.6K are in series, both the resistors will get the same current. And we can even write 10K plus 2.6K, 12.6K also we can write, because both the resistors are connected in series, means their net resistance will be sum of both the resistors, right? 10K and 2.6K. So by using this, I will find what is the current flowing through the circuit by applying Ohm's law. So through that I am getting 1.16 milliampere is the current flowing through the resistors 10K and 2.6K when the battery voltage is 14.6 volt. Now I need to find what is the power dissipation. Power dissipation formula is I square into R. So what is I? I is 1.16 milliampere. 1.16 milliampere, how can I write? 0.0016, right? 16 ampere. So this is what? 1.16, sorry, 0.116, right? 116. 116. So this is 0.00116 ampere is what 1.16 milliampere means. So this square, okay, this square into the value of the resistor. Value of the resistor is 10K. So how much it will come? Calculate. 0.00116 into 0.00116, right? Into resistor value is 10K, 10,000. So it is coming around 0.00134. Is it correct? 0.00134 watts. Is it correct, everyone? Okay. And for the second resistor, the same current into its value. Its value is 2.6K. 2.6K. K means 1000. So it is 0.00116 into 0.00116 into 2.6 thousand. So it will be 0.00349. 0.00349. Okay. So please check the answer. So anyway, the resistor, minimum value of resistor is 1 by 8. What is 1 by 8 watts? 1 by 8 is 8 watt is how much? 1 by 8 watt is 0.125. Correct. So our value is less than that. So you can go for 1 by 8 watts of resistor. Okay. So you can buy the smallest one for the sensing. Because the actual power dissipation happens is around 1.3 milliwatt dissipation. It is small value. Here the resistor can handle up to 125 milliwatt. 25 watt. The value 1 by 8 watt resistor. The cost would be around, if you buy bulk, 22 paise, 22 paise. But if you buy 5 or 10 pieces, they will charge around 1 rupee each. Any questions in the voltage sensing? Voltage sensing. Any questions, any doubts, any disagreement, any argument, please let me know. Let me know. Hope everything is clear. So today we have understood the 4S2P configuration. We have drawn the 4S2P configuration, and our objective is to how to measure this voltage, battery pack voltage, and that is not easy because we use microcontroller to measure it, and the microcontroller pins have some limitations, voltage limitation, voltage sensing limitation, and current limitation also. So we understood a method, divide the higher voltage and make it into a small voltage and give to the microcontroller to measure it. And by understanding the measured voltage, we can interpret what was the actual voltage on the top. So this is the activity which we have done today. And tomorrow I'll try to show you, write a code and show you how exactly we can measure and get the answer, so that you can correlate with the learnings what you have done today. Right. So I hope the class you understood the concepts, and I will meet tomorrow. Good night.
पब्लिक तो करती है।